Hi, I'm Maleesha Fernando. Imagine you're a dairy farmer. Every day you make decisions about feeding, health, and environment. But you don't really know how those decisions affect the milk production. So the question is, can we use AI to predict milk yield and guide farmers in making better decisions? In dairy farming, predicting milk yield and making correct management decisions are very important. But these decisions are often based on experience rather than data. So, in this project, I have developed an AI powered milk prediction and decision support system that helps farmers make better decisions using data. This system predicts expected milk yield and also provides useful recommendations based on the cow's condition. Here we have the dashboard interface. On the left side, we have the cow details such as feed quantity, days in milk, temperature, humidity, body condition score, previous week average milk yield, age, weight, and parity. We can also select the disease state of the cow, feed type, and lactation stage. Now I will enter sample values to demonstrate how the system works. I will change the feed quantity to 8 and temperature to 31 and parity to 1, feed type to hay, lactation stage to mid to make it a real scenario. Now I will click on predict results to generate the output. This system predicts the milk yield based on the given condition. This helps the farmer estimate production in advance. This section provides a summary of the situation. For example, it highlights that the health of the cow can impact production and to consider the decisions that are made to improve the yield. Here we have the performance category, which indicates whether the cow is producing at a low, moderate, or high level. The risk level helps identify if there is a potential problem that may reduce milk yield. This system also provides feed suggestion recommendations to improve production. This section detects the environmental stress such as heat or cold, which can significantly affect milk yield. And finally, the health alert indicates whether any disease condition may be impacting the production. So instead of giving a prediction, the system also suggests what actions should be taken. If I change the temperature to a very low temperature, we can see how the system adjusts the inside. This system is built using machine learning models trained on historical data, and the final model achieved a high accuracy with a R squared value of around 0.94. As for future enhancements, I would like to deploy this system as a web application so that it can be accessed by farmers from anywhere. Also, this system can be improved by integrating real-time sensor data, developing a model application and adding advanced features like disease prediction and automated feed optimization. Overall, this project demonstrates how AI can support farmers in making better decisions and improving productivity. Thank you.